All right, so we're making our Castle-Meyer reagent. So initially we start out with 100 mils of water. To which we're going to add about 15 to 16 grams of sodium hydroxide, because we need an alkaline solution. And we are adding phenolphthalein. So this is a concentrated stock. This brings me to about 2 grams of phenolphthalein. So it's about a 2% solution, phenolphthalein, and of course it's turning that fuchsia color that we expect when we have an alkaline solution, because phenolphthalein is commonly known as an acid-base indicator. And then I need to add 10 grams of zinc dust. Now the 10 grams of zinc dust I'm adding because phenolphthalein not only changes color due to an acid-base shift, it also changes color due to a redox reaction. In its reduced form, it's colorless, and in its oxidized form, it turns pink. And so we're going to use the zinc dust. We're going to boil the solution, oxidizing the zinc and reducing the phenolphthalein to a colorless solution. And that's going to be our phenolphthalein stock, which we can then mix with ethanol to ultimately produce our Castle-Meyer reagent. There we go, it's about 10. So we're using zinc dust to give us the highest surface area possible so we can get the most efficiency when it comes to reacting. All right, so we have our stock solution, and now we're going to heat this. I'm going to boil it. And I'm going to create a stir bar so we can make sure we get good mixing. Okay, so we're going to perform a few quick tests with our presumptive blood testing reagent. So we have our Castle-Meyer reagent here, which is the stock solution mixed 1:4 with ethanol, and then we have our hydrogen peroxide. And so basically what happens with our reactions, let's look at a positive control. So I have this is from ground beef, so it has blood in it. So essentially what I want to do is wet my Q-tip, pick up some of the blood from the ground beef, and then I add a drop of hydrogen peroxide. So hemoglobin present reduces the hydrogen peroxide, which then will react with the Castle-Meyer reagent, oxidizing it, and we should get our pink positive test for blood, which we actually see here. So this is our positive control. Actually, I'm going to put that right here. However, if there's no blood present, it's our negative control. What we should see is when we add our hydrogen peroxide, we should get no reaction with the water, and therefore no color change with the Castle-Meyer reagent. And so there's our negative control. So what I have here is a material that has 4 stains on it. So they are bleach is number 1. Number 2 should test positive for blood. Number 3 is taco sauce. Number 4 is soy sauce. So we're going to actually look at these stains and see whether we can differentiate them. All right, sorry, getting water all over the place. All right, so then we're going to expose this to our bleach. So we're going to add hydrogen peroxide. And then we add our Kastle-Meyer reagent. And so it's for our bleach. And I'm wetting these only because I don't think they'll pick up some material from the stain. So here we're going to swab the stain to our hydrogen peroxide. Oops. And then we add our Kastle-Meyer reagent. And you can see that we're getting a positive test. Now let's go for the soy sauce. Hydrogen peroxide, Kastle-Meyer reagent, and we get a negative test. Actually did them out of order, didn't I? So stain number 4. Stain number 3. And again, we get a negative Kastle-Meyer test. So in this case, the only one that actually reacted was the one we expected to react, which was a blood stain. And again, it's reacting with the hemoglobin. The hemoglobin is actually oxidized by the hydrogen peroxide. It then reacts, oxidizes the Kastle-Meyer reagent, which then turns the phenolphthalein pink. So there's our Kastle-Meyer. So this is what you're actually seeing on CSI. It's a presumptive test for blood, which means it's blood, doesn't mean it's human blood, doesn't give you blood type or any additional information other than it's blood, or that it's something that's going to react with hydrogen peroxide. So there are some peroxidases, things like that in vegetables that occasionally can react. So there are some things that can give a false positive, but it's a pretty good test for blood. All right, so here we are. We're going to try and do we're getting ready to do a presumptive blood test using the Takayama reagent that we just made. So I'm going to get some blood stained fibers, place them on a slide, and then we want to put a cover slip, in place. And now we need to add our Takayama reagent. So we're going to draw some of that here, and so we are going to place drops right at the edge of the slide so they get drawn under. You can actually already see that it has discolored the fibers. We're supposed to heat this until the reagent begins to bubble. Make sure we're fully wetted underneath the slide. There we go. Underneath the cover slip, I mean. But I just loaded our slide here onto the microscope so we can look for the crystals. Pyridine containing the Takayama reagent reacts with iron from hemoglobin. That's what forms these unique red crystals I was able to capture with my cell phone through the eyepiece of the microscope. This is indicative of blood.